Good morning. We are looking at Chapter 11, Unit 1. So this is where we start. So we're going to discuss organic compounds first and then get into the biochemical compounds. This is organic biochemistry, so organic biochemistry and then the biological processes, some of the metabolic processes we'll get into finally. So starting with organic compounds, what are organic compounds? Organic compounds are compounds also called hydrocarbons. So carbon compounds. Carbon compounds come under organic chemistry. Organic compounds or carbon compounds are made up of carbon and hydrogen. They're also called hydrocarbons. So organic compounds, organic chemistry is a study of carbon compounds. Organic compounds are also called hydrocarbons. Their basic components are carbon and hydrogen. And the learning goal is to identify properties, characteristics of organic compounds, and also we will look at inorganic compounds and compare and contrast what is an organic compound. How do you identify an organic compound? What are the properties of organic compounds? What are inorganic compounds? How do you identify an inorganic compound? What are the properties of an inorganic compound? So again, what is organic chemistry? Study of carbon compounds. So the most common organic compound, vegetable oil, is an organic compound. It is made up basically of two components, carbon and hydrogen, with more elements added. So we will get into all of that, but basically organic compounds, we can right now define them as hydrocarbons, compounds with carbon and hydrogen. So like I said, this is a compound. Organic compound is made up from carbon and hydrogen, may also contain other nonmetals like oxygen, sulfur, nitrogen, phosphorus, halogen. Often found in gasoline, medicine, shampoo, plastics, perfumes, we can say it is present all around us. So the formulas are written with carbon first, followed by hydrogen and any other element. So when you're setting up the molecular formula of an organic compound, the first element you start with is carbon. Carbon is the base of organic compounds. Then you go into hydrogen. Hydrogen is the next most important component, hydrocarbon. And then you can get into any other element, which we said was either oxygen, sulfur, nitrogen, phosphorus, halogen. These are all also components of certain organic compounds. Now, organic compounds have covalent bonds. So you might have learned about covalent bonding, but what is covalent bond? Covalent bond is a shared bond between two atoms. A pair of electrons forms one covalent bond. Covalent bond comes out of sharing of electrons. So organic compounds are covalent bonds. A compound is made up of two or more elements coming together in bonding. So the two or more elements that make up the organic compound come together through covalent bonds, which is sharing of electrons between those individual atoms. And these organic compounds have low melting points, boiling points, are flammable. What is flammability? Ability to burn is flammability. So organic compounds are flammable and undergo combustion. What is combustion? Burning in the presence of oxygen is combustion. So organic compounds have the ability to burn in the presence of oxygen, are not soluble in water. You can see you are mixing oil and water and they're not soluble. It's not soluble, and we'll get into that. Solubility, why are they not soluble as we go along? Now we also said initially that we are also going to look at inorganic compounds. What are inorganic compounds? Inorganic compounds are made up also as a compound made up of two or more atoms, but the two or more atoms are coming together through ionic bonds. are ionic. There is an ionic bond that is bringing the two or more atoms together. So what is an ionic bond? An ionic compound is made up of ions, and the ions have either a positive charge or a negative charge. So when the oppositely charged ions come together, they have a force of attraction that brings the ions together, and that is the ionic bond. So inorganic compounds are ionic, means they're made up of ions. They're usually soluble in water. Remember, we had discussed in the previous slide that organic compounds are insoluble. Inorganic compounds are soluble mostly and do not burn in air. And they have high melting and boiling points. So let us look at a formula for a hydrocarbon. Carbon, hydrogen. This is an organic compound. Let's look at an inorganic compound, NaCl. An inorganic compound, the way to identify would be, does it have a metal and a nonmetal, a metal and a polyatomic ion? So if there is a presence of a metal, it's an inorganic compound. Because of the presence of a metal, there is possibility of an ion. Because of the presence of a nonmetal, there is a possibility of an ion. So there is a table that compares the properties of organic and inorganic compounds. So like we said, the elements present in organic compounds are carbon, hydrogen, sometimes oxygen, sulfur, nitrogen, phosphorus, chlorine, and other halogens. These are group 7A elements. Now, inorganic compounds mostly are made up of metals and nonmetals. This is table 11.1, also in your book. So the bonding in organic compounds is mostly covalent. In ionic compounds is mostly ionic. Polarity, nonpolar, ionic. Ionic is the coming together of ions. You see the melting point comparing the melting point, boiling point, flammability, solubility. So we can see how these compare and contrast with each other. Solubility, an organic compound is not soluble unless a polar group is present. We'll get into this as we go into the chapters. An inorganic compound mostly are soluble unless nonpolar. So we'll see what polar and nonpolar is as we go along. So this is a good table to look at and review. So identify each characteristic as most typical of compounds that are inorganic or organic. So any compound that has a high melting point, go back to 11.1 please and just look up. If a compound has a high melting point, would it be organic, inorganic? If it is not soluble in water, would it be inorganic, organic? If this is the formula, would it be inorganic, organic? If this is the formula, if it burns easily in air, if it has covalent bonds. So this is a review. So let's start. It has covalent bonds. What would you say the compound would be? So going back, review. If it has covalent bonds, it's an organic compound. It burns easily in air, organic. So there is your review. I look for a metal and a nonmetal, inorganic. I look for carbon, hydrogen, carbon, hydrogen, carbon, hydrogen. Hydrocarbon, organic. Not soluble in water. I would say it's an organic compound. High melting point, inorganic compound. So now organic compounds, we are starting off with hydrocarbons. That's where we will start, and then we'll build on other elements, okay? So hydrocarbon, organic compounds that contain only carbon and hydrogen. Organic compounds are carbon-based compounds, and carbon always has 4 bonds. Why does carbon always form 4 bonds? Carbon comes with 4 valence electrons, and you have an idea of what a valence electron is. Carbon has valence electron. Carbon has 4 electrons in the outermost orbit. So when carbon is forming compounds, carbon is a nonmetal. It forms covalent bonds, sharing of electrons. So it is sharing electrons with other elements. Here we are looking at hydrogen to get up to complete its octet. Octet is 8. So carbon starts with 4 valence electrons and is getting up to 8 electrons to complete its octet, 8 electrons in the outermost orbit. So every bond is 2 electrons, 1, 2, 3, 4, 5, 6, 7, 8. So carbon is completing the octet by forming 4 bonds. So every carbon has 4 bonds. With hydrogen, there are 4 hydrogens, 4 bonds. Saturated hydrocarbons contain only single bonds. Again, this is a new term, saturated. Saturated is when carbon has 4 bonds and all bonds are single bonds. Carbon will always have 4 bonds. When all 4 bonds are single bonds, single, a single pair of electron, a single pair of electron. They are called saturated hydrocarbons. So the terms is what we are looking at. Again, first compound is methane, 1 carbon, 4 hydrogen. Again, we said every carbon has 4 bonds. This is the electron dot structure. If you remember, we talked about completing the octet. So carbon comes with 4 electrons and is getting up to complete the octet, 8. So this is the electron dot structure. This is where you are showing the bond, all the single bonds. Every bond is a pair. This pair is in the form of a bond. This is called the expanded structural formula. And this is the ball and stick model, 3D model for methane. So whenever you are setting up a carbon compound, always make sure carbon has 4 bonds. When it has 4 single bonds, it is a saturated hydrocarbon. This is another hydrocarbon. We call this ethane, C2H6. 2 carbons. So this is the electron dot structure. C2H6 is the molecular formula. This is the expanded structure. So here I see carbon 1, 2, 3, 4 bonds. The other carbon 1, 2, 3, 4 bonds. So this is the electron dot structure. This is the molecular formula. This is the expanded structural formula. This is the ball and stick model, the 3D structure of ethane. Now, what will be the shape around each carbon in this structure? So let me go back to another slide where they talk there. In methane, carbon forms 4 covalent bonds. Methane is tetrahedral. Every carbon with 4 bonds is always tetrahedral in shape. So what happens? Why is an atom, here carbon, with 4 bonds, 4 bond pairs of electrons tetrahedral? The reason being, carbon is surrounded by electrons. You can see when you see the electron dot structure that there are so many bond pairs around carbon. So all the bond pairs are made up of electrons and they are negatively charged. So all the bonds rearrange themselves around the central atom here in the form of a tetrahedron with an angle of 109 degrees between each bond. So here, every carbon is a tetrahedron. You can see this in the ball and stick model. You will see the 3D structure. All the bonds have an angle of 109 degrees between each other. So in the butane molecule, C4H10, every carbon is tetrahedral. Each carbon atom has 4 single covalent bonds and therefore tetrahedral shape. 4 single bonds around a central atom leads to tetrahedral shape.